Yeah, no problem.
Hey, we got a table for you set up over here.
Great.
And, we've been looking forward to this because you've been doing some correspondence back and forth with Steven Streufert and myself.
Yeah.
And you end up taking a look at our graph.
Yeah.
Our grid map. And you said, hey, you know, I can do with a little bit of math, I can figure out the accuracy based on the angles and the stumps of the trees.
Yeah.
And the position of the 1971 Renee DeHinden overview shot.
Yeah.
I go, great. So Steven goes, well, I already sent it to you. So then within about a week or so, you send back this preliminary thing going, I think you guys are right on.
Yeah.
And then you send back this complicated mathematical angle stuff. I'm going,
well, you know,
looks good, but what does it mean?
The first impression when you compare the two is that they're a match, but you gotta actually compare all the angles and the geometry of the objects in the survey with the objects in the photo. And I did that trigonometrically, and everything matches up. So I just used a standard
you got it right here.
Standard calculation, yeah. So here's what I used to derive the camera angle here. What I did, I don't know if this is bright enough to see.
Okay.
But so what I did is I took two objects that were rather far apart, and those same objects that were identified in the survey here.
Oh, so what you did? See, like when I did the survey, I labeled these like K and P. So you
so
took those landmarks.
I used those same labels. So what I did is I took the actual length. So I took a measurement on there. I did it trigonometrically. I didn't use a ruler, but I mean you could use a ruler if you wanted to. So I took the measurement of that line, and what I did is I calibrated a ruler over here to make that exact same measurement. And then since that line is rather perpendicular to the camera, it'll form a good triangle. You don't have to normalize for any of the offset angles or anything. So what I did is I picked another object in the top. This is object V up here, and I drew a ray to the camera, which forms a 90-degree angle. It's about 90 degrees, not perfect,
but close.
Yeah, it's close enough for when you're doing this. So what I did is I took that line and I measured from here. This is 4.1. This one's 6.3, and I translated that over here. So what I did is I created the point, so the point appears right there. I used the calibrated ruler to find it there.
Right.
So I just created the same triangle over here.
So this line right across here.
Yeah.
What does that compare with the?
That line compares with this line here.
So that's line right there.
Yeah.
Okay.
So that's the exact same line.
Okay. So it looks weird because this is like a triangle this way.
Yeah,
and this
but it's viewed at an angle. So the triangle is actually, it appears smaller.
Okay.
So what I did is I made an exact measurement of this line. I used monument V and then point delta. I took a trigonometric reading on this line here, and it comes out to 12.8, which is 120.8 feet, because this is 10-foot grids.
Yeah, 10-foot grids on the map. Yeah.
So that's 12.8.
10-yard.
And then the measurement here is 3.7 when I took the 3.7. So I used my calibrated ruler again.
Right.
I measured 3.7 on there. So what I did is I plugged it into this equation here, which is the actual length of delta V.
Okay, and that's that little blue thing.
Yeah, that's that blue line right there. Multiplied by the camera angle over 90 degrees equals the measured line. So this one's the measured, and that's the actual length.
Right.
So measured is 3.7, actual is 12.8. So 12.8 times the camera angle over 90 degrees equals 3.7. And a little bit of algebra, just move that around. So the camera angle is equal to 90 degrees. 90 degrees times 3.7 divided by 12.8. Therefore, the camera angle equals 26 degrees. And that's the average camera angle for that.
So I'm back to this up a little bit. So 90 degrees.
Yeah.
Did you estimate that? How did you come up with that?
Well, the 90 degrees is a vertical view. So like this is viewed. I just plugged in. So when you're viewing straight up, let's say your angle would be 90 degrees over 90 degrees. So that's
straight up and down.
Yeah. So that equals 1. So that's 100% of this line. So 12.8 times 90 over 90 is going to equal 12.8. So that's what you're going to see.
Okay, that's
yeah. So if you angle the camera down. Let's say you angle the camera down halfway, and it's 45 degrees. That line's going to be half as big. So it'll be 45 over 90, which is 0.5. So you multiply that by 0.5, and it gets shortened.
Okay,
so it's not too complicated. If you set it up right, it doesn't have to be too complicated. So I got a normal camera angle of 26 degrees. I used a couple other objects. If you use an object a little bit more different, the angle comes up to a little bit more. And if you use one that's a little bit close to the camera, or if you use one that's further away, it comes up to a little bit less of an angle. And one that's closer to the camera is going to be obviously more of an angle.
You also did some others in there too, and you did some farther to the side and some more direct.
Let's see here. Let me see here.
Yeah, this is cool. Who drew this? This is really cool.
Oh, this one? There you go.
There it is.
Yeah,
that's the grid map.
That one.
Yeah, so this is the grid map that he used. We Rowdy, myself, and Steven Streufert did on the site, and he was talking about the B one, which is just over here a little bit.
Yeah.
There it is, right there.
Yeah.
So we gridded this out. So he's taking the measurements, angle measurements, and applying them in off the film, and the 71 overview shot, and this grid map we did. So it was just pretty incredible.
Yeah.
So go ahead and show me some more of your.
All right. So let's see if I can get it going. Let's see here.
That's the one you did with P and
yeah.
R.
This is a different one that I did.
So you're doing this one off the big tree.
Yeah.
This is off the big tree.
Yeah. So what I did is I did the same basic thing. I just trigonometrically found that angle. So let's see here. Actual length 26 over 90. So yeah, this one's close to 90. I didn't normalize for the angle, but it comes out about right. Which is pretty much what everything comes out at, Let me see. Here's a good one.
Yeah. So I remember this spot right here. This is like a. Oh, it doesn't go up. I'm sorry.
Yeah.
Don't touch the equipment, Robert. Thanks. Yeah. So, this one's pretty noticeable because in the film, this tree is not there. This fell down. This is the top part of the snag that's right here.
Yeah.
It fell off. So this is like after the 71 shot, too.
Oh, okay.
But that's that stump.
Yeah.
We've been there many times. I recognize this guy right here.
Yeah.
But yeah, so use that stump right there. That's actually in the shot in 352. It's in the corner of the 352 shot. Yeah, and this is the big stump hidden on the side of the tree here. And they use a debris pile down by the bowling alley.
Yeah.
And you use a real distinct stump that still has the shape of a stump.
Yeah. All right, so what I did is I basically found 3 objects that were in about the right spot in order to get a good number off of them. And I just translated their triangles over and created similar triangles.
Yeah.
And this is what it looks like. So what I did is I came up with measurements for all of the rays that were going to the camera. So all these rays actually point to the camera.
So that's the 71 aerial shot, correct?
Yeah.
The blue is looking this way.
Yeah.
Okay.
I mean, even from these numbers here, if you go to the survey, you could, rig up a laser or something like that and point out exactly where that shot was taken. So it's pretty cool.
Yeah, it looks really. Yeah.
So what I did is I created some rays here to the camera. I translated them, and what I did is I plugged them into the same equation that I used for the other one. So basically, you get a predicted point for how long these rays are going to be, just by using that angle at 26 degrees.
Let's just go with the purple ones.
Yeah.
Show me what the firm is for the purple one.
So if you use this purple line here, that one I used FK. So object FK, the distance, the actual distance is 11.8. When you multiply it by 26 over 90, it equals 3.4. And when you use your calibrated ruler over here, it comes out to 3.5. So that's accurate. If it was 3.9 or something, then I'd have to go in and check and double, check everything and say, okay, well, maybe that object isn't labeled right or something.
Right.
But for every one that I did, it measures up and matches good with that angle. And I based everything off that same first line that I did for my angle calculation, just because that'll keep everything. Yeah, so that'll keep everything normalized. But I mean, it's not too complicated. I try not to use too much trigonometry. So anybody who wants to verify the position of an object can do so. Most everything matches up. The only ones that kind of didn't match up, there's a couple of them that were some of the logs I could see were flipped around and things, and the trees matched up. I did one to every one of the trees, but I mean, you probably didn't want to see 40 triangles. At first I was going to use these trees as the angles, but I mean, I figured it'd be better for something to have a little bit more of a spread. But these all come out okay. The stumps come out okay. I started working off the stumps, and the stumps are all they measure up. So everything works pretty good. So I mean, in my opinion, it's an accurate representation of the actual PG film site.
You finished the survey, so what I mean, you think this tool is going to be good to use in the future?
Yeah, I mean, the survey really has many uses. I think the primary purpose of the survey was to verify the location of the PG film site, and that's been done. That it definitely matches up, and that's this is definitely the that's definitely the location of the PG film site. Another purpose is anybody can go to that site, and they can plug that survey in, and they can map out where the creature walked or whatever, and they can walk in the footsteps, or they can do whatever surveys they want, or any other supplemental data. But I mean, the survey is done with such great accuracy that everything's mapped. So I mean, it's all there. And thirdly, you could use this. You could use the survey as a tool, so you could maybe get historical landmarks at status. So
I never thought about that. Yeah.
So that might be another step. Now that it's been verified. So yeah.
Cool. Well, I appreciate that. That was a lot of work you went on that. And how long did it take you to get all that stuff done?
Oh, it wasn't too bad. It was mostly just the Photoshop work. Doing all the making it look pretty, and then doing the write-up and things. That's what took the most time. But
nice, looks good. I mean, you did it. Nice job.
So yeah, it wasn't too much work. So so I'm happy with it, and everything works out, and everything's good. So
we're happy with it. I appreciate it. Thank you very much for your time.
No problem.
Nicely done.
Cool. Thank you.
All right.